Bismillahirrahmanirrahim. Today we are going to conduct lecture number 21 of this course, and today's topic is bit manipulation instruction. Let's see what are bit manipulation instruction and why they are useful for our programming in assembly language to program when we are going to program microcontroller PIC18F 452. So let's consider an example program to understand the beauty of uh, bit manipulation instructions. Okay, I have written a code. Let me explain you so that we come to know what this program is actually doing. Very first instruction is BCF, which is bit clear file. This is the first time we are using this instruction, and this is one of the bit manipulation instruction of PIC18F microcontroller. So BCF instruction, what it does, uh, it actually saves or clears zero in file register in a specific file register, and in that file register in a specific bit. So what it actually means, bit clear file, that means we are clearing a specific bit of a file register. And what file register we are using? TRISC, and we mention here zero. So that means we know that in TRISC we have how many bits? We have 8 bits, right? 8 bits available. So this zeroth bit, because we mentioned here 0 bit, right? This zero is not a destination bit here. This is basically what this is a bit number, right? So we make this bit equal to 0, or we clear it because we use word clear, BCF bit clear file, right? Uh, Here we can, I could actually write BCF trace C comma 7. That means I'm interested to make bit number 7 of press C equal to 0. That means this bit number 7, right? This is bit number 0, 1, 2, 3, 4, 5, 6, 7. So 7 is the last bit. So it will become 0 if I'm going to write this instruction, but this is not the part of instruction. So we will not be considering this point, right? So I hope this point is clear. So what is going to happen? Press C's 0 bit is going to be 0. And you know that trace is used. Why trace is used? Trace is used to make the specific port uh, either output or input. So we are right now configuring port C's 0 pin equal to output pin. So what we are doing, we are making RC0, which is RC0 is what? 0th pin of port C, and we are dealing it or declaring it as output pin. So this is the first time when we are making just single pin, either output or input from a complete port. We are not making complete port either in output. We are just making the port C 0th pin, right? So if you consider port C and you have 8 pins, so RC1, RC2, RC3, RC4, after this execution of this instruction, they will remain input pin, but only RC0 has become output pin. I hope this point is clear. Then we go to the next instruction, which is bit set file. As I told you in the last lecture and in this lecture as well, set means equals to 1. So what we are doing, bit set file, we are making one of the bit of the file register equals to 1. And what file register? Port C. What is the port C? Port C is a output port. Oh, sorry, port C is available port, but it's 0th pin. We are considering here 0th pin, which is our output pin. So if this is our microcontroller and this is port C, so we are only considering RC0. This will become equals to what? Equals to 1, because what we are doing, we are setting it equal to 1. Bit set means 1, clear means 0. So bit set file, we will make it 1, so it will become equals to 1. Okay, then what we do, there is a label, we ignore it. Then we go to call delay. Call is calling a subroutine whose name is delay. We go to subroutine, and what this subroutine do? This subroutine just create a delay of 1 millisecond. So what will happen when this subroutine finish? We will have a delay of 1 millisecond. So RC0 is on, right? RC0 is equal to, for example, this is the bar chart, or this is a graph of RC0. Earlier it was 0, and it become equal to 1. So it will remain equal to 1 for how long? For 1 millisecond. for 1 millisecond it will remain 1. Then what happened, we go back and we go back to this sorry, where I was. let me Let me clear this. Yeah, undo. Yes. So here I actually jumped to delay. So what will happen? I will come back and next we will execute this instruction, which is BCF. BCF means bit clear file. A file register, a single bit would be clear. And what file register? Port C. So again, we are dealing with port C and we are making this 0 pin. Earlier we made it equal to 1 and now we are making it equal to 0. So this will become again 0. And then again, I'm sorry. Then we make it, we call delay. So it will go for 1 second. So this will remain down for 1 millisecond. I hope this point is clear. And then we branch again to this point and then repeat this procedure. So it will again equal to 1 for 1 millisecond. It will again equal to 0 for 1 millisecond, and this process will continue for indefinite time interval. So what we are doing, we are creating a square wave using this mid manipulation program. So what we learned in this code, we actually can make bit manipulation instructions. We can make individual pins, either input or output. So this is the question we have taken in so many last lectures, that can't we just simply make few bits input pins and few bits output pins from a same pin? So we can do it using this manipulation command. I hope this point is clear now in your minds. Okay, I'm going to explain one more interesting program for bit manipulation. And this time we perform bit manipulation using some conditional jumps. So let's see what we are doing. So very first instruction that we are understanding is clear f T. So this is the instruction we have already done. So I will not explain what is the thing. It is clearing complete T. So that means complete port will match output port, because tris t will become 0 0. Every pin of tris d would become 0 0. So port d will be treated as output port. Then it is a level, so I'm just ignoring it. What is this instruction? This is the very important instruction and we are doing it very first time. So just listen to this very carefully. What is it? It stands for bit test file. We have to test a file register, but not complete file register. We have to test a single bit and skip if that bit is set. This double S means, let me write it for you. This indicate bit test file skip if set. So we are testing a single bit of a file register and we will skip the next. What we will skip? We will skip the next instruction. This is the beauty of this instruction. We can skip the next instruction. That is why it is known as one of the branching instruction, right? So what we have to do, we have to check the specific bit of a file register, which will be mentioned, of course. And we can see that this is port B. So we are testing the port B and what bit number 0, right? So we are testing port B, bit number 0, we are testing it, and we will skip the next instruction. And the next instruction is branch no, right? It is a unconditional branch. We're gonna skip it if that bit is going to be 0. So we are testing a bit. So port B is your input pin. That is why we are testing it. And we know that for input pin, we don't need to declare it. That is why we did not use any tris B thing. So we port B is by default input pin, and we are just checking 0th pin. So what we check, if 0 pin of port B equal to 1 or not. If it is 1, then we will skip the next instruction. So for sake of our dry run, we consider, let's say RB0, which is the 0 pin of port B, is equal to 1. So our branch condition will be true. So if this condition is true, we're gonna skip the next instruction and we gonna jump to this part, right? We skip the branch no condition, which is the next instruction, because the condition was true. So what is this condition? This instruction says move literal working a y in apostrophe. I hope you remember, this is the one of the way by which you can define ASCII character. So y is saved in working register, and then what we do, we actually move that working register into port D. So we are sending, port D is our output port. Remember, we set it make it output port in the start. So what we are doing, we are sending this working register value, which is ASCII Y, into port D, and then we repeat our procedure, branch again, and we will come back to this point. I hope this point is clear. We perform this task when RB0 is equal to 1. Let's make it 0, and now perform this program again. So what we will do, we will again test this code, bit test file skip ifsat port b comma 0. That means we will test the file register port b, and what bit we will be testing 0 pin, and this time it is 0. So this condition won't be true because this is not equal to 1. So that means we can actually not skip the next instruction, we will run this instruction. So what is the next instruction? Branch no. So this is forcing us to jump to level no, right? So we will come here no, right, to this level. And now what we are doing, move little to working. Okay, there is a mistake, let me correct it. Yeah, I corrected it. So what was the mistake I read? I just wrote it by similar, so I wanted to make a different case. So in no level, what we are doing, we are loading ASCII value n or character n in working register, and then we are sending to port D, and then we repeat our code again. So I hope you remember, you have understand this code. And in this code, what we are doing, if RB0 is equal to 0, then we are sending letter n, and if RB0 is equal to 1, then we are sending letter y. Let me write the statement for you. So this is the statement that I have written for you. What we have to do, we have to check the RB0. If it is high, if it is equal to 1, then what we have to do, we have to send Y to port D, right? That is why we made port D as output port. Otherwise, we have to send N to port D. So I hope you have understand this code. And now you have used a conditional branch, which is basically bit manipulation, but works on a specific bit of a specific file register. Okay, that's it from this lecture. If you have any confusion, please post in comment section. Thank you so much for listening.